All right, 3.4, graphing systems of inequalities. Systems of inequalities. Like any system, we're looking for the intersection, only in this case, you're going to have an infinite numbers of points of intersection. It's the exact same concept. So the solution of the system is all the points of intersection. All the points of intersection. So I have two inequalities graphed. The blue inequality is what kind of a function? Blue one. Absolute value, right? You see a V shape, it's got to be absolute value. What would the symbol, what would the inequality symbol be? Is it a less than or equal to, greater than or equal to? It had to be a greater than or equal to, right? Because it's a solid line and we shaded above. The green one is a linear inequality, right? Because it's a line. And what would be the inequality symbol? Less than or equal to, greater than or equal to? Less than, right? Because it's a dotted line and we shade it below. And you can see in red clearly the intersection, right? So all those points there in the red, and technically these points of the blue, right? So all the blue from here to here, and that didn't show up very well. Here, let me do yellow, right? All this blue as well is part of the intersection, right? Part of the solution. The points of the dotted green line are not part of the solution, even those that are right there, right? They are not part of the solution because you don't have both. So anywhere where you see both, that's going to be the solution, and that's what you're looking at, and that's what you're looking for. Hey, we could graph 3 inequalities or 4 or 50 if you wanted to. But the solution has to be where all intersect, and hopefully that makes sense, right? It's got to be where you see everything. Where everything intersects, then that's going to be the solution to the inequality. All right, so let me refresh your memory on a couple things that can tend to get students a little backwards. So look at A there, x greater than or equal to 0. So this is anything that's going to yield an x value greater than or equal to 0. So this would be a solid line along the y-axis. Because what's the x-coordinate of every point on that line? It's 0. And we have an x greater than or equal to 0. And then all the shading is going to be off to the right. Because no matter what point you pick to the right, it has an x value greater than or equal to 0. Again, the mistake students make is they want to do the second one for an x greater than or equal to 0. Because they're thinking x is the x-axis, draw the line along the x-axis. And that's not what it is. Okay, we need all the points where an x value is 0 or bigger. So all positive x values including 0. So the second one, b, y greater than 0, is going to be the dotted line along the x-axis. And then you're going to shade above, right? So again, just for clarity's sake, if you look at this point right here, right, the y value is a positive 3. The y value is greater than 0. This point here, the y value is positive 1. The y value is greater than 0. This point here, the y value is a half. The y value is greater than 0. Again, anything above. So if it was less than 0, you know you shade below. If it was less than x, you know you shade left. All right, hopefully no big deal there. So let's do a couple examples here, solved by graphing. Let's see if I can get a little bit higher. Okay, so 3 is kind of nice for you. It's already in slope-intercept form. So go ahead and do 3. Just remember dotted line and solid lines, and then where you're shading above or below. Dotted or solid, above or below. And when you're doing these on a quiz or a test and using pencil, you just darken in the part where the solution is. Right? Hopefully that's about what you have. So y-intercept first. So the black ones start at 0, 4. Use your slope down 1 to the right 5. Dotted line, less than, shade below. Blue one, start at -2 on the y-axis. Slope is 3/5. Go up 3 to the right 5. Solid line, because it's greater than or equal to, shade above. Where do you see both? In the red area. Okay. All right, so number 4. Questions on 3 before I go on? Anybody? Questions on 3? All right. So number 4. When you look at the black one, hopefully you think absolute value because it's got absolute value symbol. You're thinking V shape. So again, if you understand the quick way, you understand that the vertex of this thing is at 2, -3. And that really does help you. Just be careful. Don't say -2, -3, because then you'll think you're right and you're going to be off. So 2, -3. So I stick the vertex right there. By the way, this V can go upside down. There'll be a negative out front if the V goes upside down. And there's not, so it doesn't. And you might not always be able to read the slope if the coefficient of the x isn't a 1. You can if you put it in the right form. You have to factor out that value. So again, that's a little tricky. But this one's a 1. If you don't know what the slope is from here, use an XY chart. So let me do it that way because most of you would. But here's the point. I'm already at a 2 on the x value, right? So I'm going to go 1 away. I'm going to go 3. I'm already at 2. I know where 2 is. I'm going to do 3. So I do 3. 3 minus 2 is 1. The absolute value of 1 is 1. 1 minus 3 is a -2. And again, you see the slope is a 1 on this thing. And you know that's enough because I know this is the vertex. And I'll go 1 on the other side, even though I know it's going to be there. But you might not. So we stick in a 1. 1 minus 2 is a -1. The absolute value of -1 is 1. 1 minus 3 is a -2. And sure enough, there we are on the other side. And this is less than or equal to, so solid line, and this thing we're shading below, right? Okay, and then the second one, just be careful putting in the slope-intercept form. Notice every time I keep trying to remind you to remember to reverse the inequality symbol when multiplying or dividing by a negative. I keep trying to remind you in practice problems so you won't forget when you got to do it. So what do we end up with? A 1/2 x and a -1. So y greater than 1/2 x minus 1. I think That's right. So y-intercept of -1, go up 1 and to the right 2. Go ahead and do a dotted line. Shade above the line. And so for this one, the way our graph is set up, we're shading in here, right? Are we accurately portraying the solution set to this? Are we completely portraying the solution set to this? Because extending your brain, what's going to happen here to the right? Do you agree the black one's going to continue up and have stuff under it, and the blue one's going to continue out to the right, and it's going to go up, and you're going to have a red field to the right as well, right? So I wish I had a little bit more room here to the left, and I don't. And I can't move everything because if I move it, the ink won't move. But the reality is here to the right, this thing keeps going, and there's definitely going to be some red going up in a V or in a triangular shape up that way as well, right? That's what's going to happen. And that's because, again, we were below and we were above, right? Any questions so far on those? Kind of stuff we already know how to do, right? So the last one just has 3. Not a big deal. Why don't you see what you can do with that? Is that what yours looks like? Something like that? Right? You're above the black. You're below the blue, below the green. You're looking for all 3. Tough thing with a problem like this is you got to convert all 3. You got to graph all 3 correctly. So just the probability of a mistake goes up. Any questions? Anybody? Okay, I'll leave that up for you. Hey, you guys got a good 15 minutes to get going here. You can see the numbers on the bottom of your page. I tried not to give you a ton because hopefully most of you are decent here, but hopefully enough to get you going. You're going to need graph paper. Borrow some if you need it. And don't obliterate and ruin your graph.